Hello everyone, in this video I'll be solving the kth closest element. This problem is from Geeks for Geeks and it says you are given a sorted array, the array is sorted, okay, ARR of unique integers, okay, they have given ARR, an integer k they have given and a target value x. Return exactly k elements from the array closest to x, got it, excluding x if it exists, okay. So an element A is closer to x than B if modulus of A minus x is less than B minus x, or if both are equal, A minus A equals to B minus x, so and A is greater than B, that is prefer the larger element. Okay, if let's say A minus x equals to B minus x, so in that case we'll have to prefer the element which has greater value, okay. Return the k closest element in order of closeness, okay, how close they are we'll have to return in that way. Yeah, it is an easy problem only. Let's try to take example and explain you on the board. 1 3 4 10 12. Let me take you to the board. What was it? 1 3 4 10 12. I think array was, this is first example, 1 3 4 10 and 12, and k they have given is, I think, k is to x is 4, k equals to 2, x equals to 4. So we'll have to find two closest value. Conditions they have given is we'll have to find a minus x less than b minus x. So we'll have to find this way, and if both the elements are equal, a minus x equals to b minus x, so in that case we'll have to prefer, let's say a is greater than b, we'll have to prefer this a. So how do we find this? So one thing to note is that since array is sorted, so and also in question they are given this x what we are finding may exist in the array or not, but in this case if you say we have an 4 here which is basically x, so we'll have to find the two closest value now, okay. But one thing to note is that this, since the array is sorted, so it is very easy to solve this problem. If the array was not sorted, then it would be difficult. So see, what we'll have to do is we'll have to find this 4. How do we find this 4 in the array? So one thing is we can use linear search. Uh, Linear search is okay. It will take time complexity of O of n. But what if we use this binary search? Since we know, since arrays are sorted, so binary search can be used, and this takes log of n time. That's it. So we'll have to find the element x in the array. So let's say we found the element x here. So let me call here it as index idx. This is the index where we found this element, and now once we found this element we'll have to take two indices, which is basically L, and this one will take as R. Now what we'll do is we'll try to find the difference between this L and index. So array of L minus array of index, which is basically x, okay. This array of index is here 4, which is basically x, so we can replace this by x only. So we'll have to find the absolute value of this. We'll have to find the array of r minus x, again absolute value of this. These two things we'll find. First let's find the we have L here, so it will be 3 minus x is basically 4. This will give as answer as 1. And what about this? Array of r is basically 10 minus x is 4. This will give answer as 6. So clearly, as you can see, 1 is less than 6. So we'll be choosing the closest value as array of L. So what I'll be doing is I'll take one vector which is answer. In answer I'll be storing array of L. Array of L is basically 3 in this case. Once we found this 3, since this is the middle element, we have found this one, so we'll have to move far apart and check it. So this one was the not closest value, this one was closest, so we'll move this left pointer to at this position, the again left position, Okay, one value I found, so we'll decrease k by 1. Okay, so let's try to find again same thing. In this case, array of r was remaining same only because r we are not doing anything. So array of r is basically 10 minus x is 4, this is 6. But if you see here array of l, which is 1, x is 4, so this will give answer is 3. So again, if you see 3 is less than 6, so in this case we'll choose array of l. So array of l is basically 1. Now we'll decrease k count by 1, so it is 0. So since we found 2 elements, we'll stop our iteration. So as you can see in the problem also they have given 3 4. I think you got how do we solve this. So there are some of the edge cases as well. Let me explain you edge cases. Two edge cases we'll have to consider. Edge case 1 I'm discussing. Let's say array elements are 2, 3, 4, 5, 6. This is the array elements, and the value x they have given is, let's say, 1. So in this case, if you see 1 is not there, so 1 is even less than this first element. Okay, so 1 is somewhere here if you see, and let's say k given is 3. So as you can see, 1 is not in the array and it is less than the first element, so we can take these 3 consecutive values. Reason being, we'll have to find the closest value. So this one is first closest, this one is second closest, this one is third closest. If you, let's say, try to take 2, 3 and 5, but this will be not that close because 4 is more close than the 5. So if you see difference, 1 minus 4, this is 3, and if you say 1 minus 5, this is 4. Obviously this is smallest, so this is the first edge case. If the value of x is less than the first element, which is x is less than array of 0, so in that case we'll take first k elements and return it. This is the case 1. Now again, if you see for the second case, so that will be a reverse case. Let's say we have value 1, 2, 3, 4, 5, and our k value is, let's say, 3. Okay, and x given is 6, let's say. So 6 it will come here. Okay, and if you see 6 is not lying, and if you see 6 is greater than the last element, so in that case our closest value to 6 will be these 3, not these elements. If you take, let's say, this element, its difference is 2 minus 6, which is 4. Its difference is 3 minus 6, which is 3. Its difference is 4 minus 6, which is 2, and 5's difference is 1. So if you see, the closest value is 1, 2, 3, so we are taking this. So these two are the edge cases. Got it? Now one more example I'll explain you, wherein we don't have, let's say, x value. So let's take array element as 2, 4, 5, 7, 9. Let's say x given is 8, and we'll have to find k is equal to 2 adjacent elements. Now if you do a search, we don't have any element. I mean, we have elements, but we don't have x target element. So what do? We do a binary search wherein we try to find x. So our index that will be pointing will be at this 1 greater than the x, that will be pointing to this. This in the code I'll be explaining you. But what you will have to assume is that whatever value is there, if that is present, so that our index idx, what I was referring, that will be pointing to that element. If that is not there, that index will be pointing to the next greater element of x. Okay, we'll take for example 6 still more values to understand. So our index will be pointing to this. So whenever our index is pointing to this element, so after binary search, we'll try to find array of index. If array of index, that will be equals to x, which means we have found the element. Okay, but in this case array of index is 9, and x is 8, so 9 not equals to x, we don't have that value, which means our left pointer now will start with 1 less than the index and right pointer will start with the index. Okay, somewhere here we are assuming that 8 should have been there. So now we are trying to find the again same way array of L minus x and array of R minus x. This we are trying to find again. So yeah, this was one of the again case. So let's try to code it up. I'll tell you in the code, so don't worry. So let me put this video on the corner. See, what we'll be finding is they were asked to find if the closest element. So we'll try to find, let's say we'll take index equals to minus, first let us don't take index. First what we'll try to do, we'll try to take one vector which will store the answer. First case to be checked is that if ARR of 0, the first element what we are having is greater than the x. I told you in the edge cases. So in that case, the first k elements will be our answer. So we'll iterate through the loop I less than k, I plus plus. We'll insert these first elements ARR of I and we'll return our answer. Okay. Now this case is handled. Now one more case will be the array, the target what x we have that is greater than the last element. So let's take n as the size of array. Okay, now we'll have to check if array of n minus 1, n minus since array index starts with 0, so the last element will be at n minus 1, so that is less than let's say x. So in this case also we'll have to take the last k elements from the backwards, right to left. Int I is equal to n minus 1. Let us take this way. Int I is equals to n minus 1 while k greater than 0. What I'll be doing is I'll be taking k elements from the end. That how I'll be taking, I'll show here. Answer dot pushback. I'll take array of I minus minus. Basically I'm taking array of I element, I'm decreasing the I pointer to the left side. Okay, let's say array element is 5. There are 5 elements, 1 2 3 4 5. So this I will be pointing at 4 because n is 5, 5 minus 1 is 4, and after taking the last element it will point to the third element, and at the same time we have to decrease count. Since we have taken one element, we will decrease the count, and when we are coming out of the loop we'll have to return answer. So these two edge cases are handled now. Now we'll do a binary search to find the element, which means the element x either lies in the array range or I mean that definitely lies in the array range, but we'll have to find if that element is present or not. So for that, what I'll be doing is I'll take index, and I'm sure that index will be finding, even if the element x is not there, we'll be pointing to the next greater element. I'll take one variable left which will be initialized to 0, right which will be initialized to minus 1. I'll do a binary search left less than equals to R. I think you guys know how to do a binary search. So we'll take mid index as R minus L divided to plus L. So this is basically to not go out of the integer overflow. Binary search you can see in any of the videos. So yeah, now we'll have to find if array of mid, the index what we are getting, mid is the index what we are getting mid, and then we'll have to check if array of that element present at the mid is equals to x. This means index is mid, and we'll have to break it out. Means we have got that element, we'll have to come out of the loop. Now we'll try to take left and right and find the k closest elements. But what if array of mid is greater than x, meaning here the mid element what we have got, that is greater than the value x. So in that case right range will have to decrease. Let me show you. Let's say we have something like this. We have x as let's say 4, or let's say mid is we have got something like mid is this one. So if you see mid, array of mid is greater than x, so in that case we'll have to decrease the range, right? So this mid r will be somewhere here, so r has to decrease by mid minus 1, so r will come here, and let's say L was here. So yeah, what we'll have to do is we'll have to decrease r by mid minus 1, and also index will be mid. Reason being, let's say the same example, let's say x what we are finding is 3. So in that case let's say mid is now here and we have came here, so mid we have got left and right range. Now again we will try to find mid. Mid will point here, okay, m will point here. Now if you see array of mid is 2, which is less than element 3x, so in that case we will be increasing our left pointer, so our left pointer will come here, mid plus 1 will do. Okay, now left and right we have, and mid will point to here only now, next time in the next iteration. So now we'll try to find if array of mid, which is 4, if it is greater than 3, which means right pointer will be pointing to mid minus 1, or right pointer will point to here. So as you can see, our answer will be at the L index only. Okay, what I'm trying to say is that let's consider L case. If equal, greater than, less than. If it is less than, so our left index will point to mid plus 1, and at the same time, 1 second. So yeah, this is correct, but I am trying to find the next greater element. So the next greater element will be at index mid minus 1 only. Yeah, it will be at mid minus 1. So let's say we have found the index. Now we'll have to check if array of index that is equals to x. So in that case we are having the element that in the index. So in that case let's take left, that will be pointing to index minus 1 as I showed in the example, and r will be pointing to index plus 1. Else if that is not there, in that case since our pointer will be pointing to the next greatest element, so r will be index only, f l will be index minus 1. Okay, some we got this L and R. Now we'll have to check, we'll have to take vector answer. Vector answer we have taken already here, so we'll have to one by one move left and right. So let's take int left, while k is greater than 0, that is first condition, because we'll have to find only k closest elements, and yeah, left should be greater than or equals to 0, that is true, because left is moving from right to left. It will move from index minus 1 to till 0, it shouldn't go beyond 0, and right should be less than n, that is the condition. Now we'll try to find here, if absolute value of array of left minus x is less than absolute value of array of r minus x, this is according to the condition. So in that case we'll be choosing this array of left. So what we'll be doing is we'll put in this in our answer vector array of left, and will decrease the left count as I showed on the board. Else if what will do, if absolute value of array of left minus x is greater than absolute value of array of r minus x. This is according to question only. So in that case we'll have to choose the right element. So answer dot push back will be array of right, and since we are taking right, so we'll have to move one element to the right side, so which is plus. Else one more condition was there, if both the elements are equal, I mean this difference absolute value, in that case see we have taken the less condition, right condition. Now if we are trying to get this it will go to the else condition, and in the else condition, which means these absolute values are different, so we'll have to check the a and b greatest value. If array of left is greater than array of right, so they have asked in the question you'll have to choose the greater element. So we are taking answer dot push back as array of left, it will be decreased by -1. Else we'll have to choose the smaller element, array of right plus plus. I think you guys got this. Now there will be some of the cases like your k is let's say you have index and your L is moving in such a way that it came out of the bound, like L value is beyond 0, which is -1. So now your k value is still there, you will have to find the k closest element. So in that case you will have to choose directly the right elements because arrays are sorted. So that case I'll be writing. So while k is greater than 0 and left is greater than equals to 0, this case I'm writing it for right bound overflow, means right side whatever r value is there, it has came r value, r index is at n, so we'll have to take all the L values. So what I'll do is I'll put this answer of left minus minus, and k will be decreased by 1, and here also in the loop k should be decreased by 1 or else it will go till infinite loop. And below is the left bound overflow while k is greater than 0 and r is less than n, which means left side has gone to -1 but right side still is there and k value is still greater than 0, so we'll have to take the right side values. Okay, once we come out of these loops, so we'll have to return answer. Let's try to run the code. Yeah, it got accepted. Let's start to submit the code. So it got accepted. This one, let me tell you, I think you guys are not clear why I'm doing this. So in case of right, I'm doing this thing, right? Array of mid greater than x. So what I'm trying to do basically is that let's say we have a value 1, 4, 5, 7, 8, 10, 13, something like that. These values we have, and our x is let's say 6. You'll have to find a target of 6. Okay, left pointer is here, right pointer is here. So mid or will be this one 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. This is the index, so it will be 0 plus 6 by 2, which is 3. So mid is this. This is the mid. Now we'll be checking array of mid, which is basically 7, equals to target x or not. This is not correct. So we'll go to again if condition, this 7 is greater than 6. So One thing we know is that 7 is greater than 6, which means right range will have to obviously decrease by mid minus 1. That is true. So right range will come here, but our answer index may be this one. Why? Because as you can see, 6 was supposed to be here, but it is not there. But if you move the right index to this place, so it is lesser element. We are trying to store the one element greater wala indexed. So that is the reason index I'll be storing it as m. In case of array of mid greater than uh, array of mid greater than x, target value x. So I think you got how why I am doing this thing. So yeah, so this like let's say r will go here. Now we'll try to find mid. This is our mid. Next mid. This will be actually erased. So you will find here which is 4. Array of mid is 4. If it equals to 6, wrong. 4 is greater than 6, wrong. It will go to else condition. Our left pointer will point to the next element. So we have L here. So this will go away. Now mid will be pointing to this index only. And if you see phi equals to array of mid, which is phi equals to 6, which is false. 5 greater than 6, we are finding that is also false. Now it will go to the else condition, last else, and that is basically L will be increased to m plus 1. So mid is here, so our L will be increased to here. Whenever L crosses R, in that case we'll have to return. So if you see in this case, we are storing the index, the next greater element in the index, which is when R was basically decreasing. So when R was decreasing, we are trying to store this index as the our answer, like the first index. And in this case, since we are like we have found the index value as this one, so 6 was supposed to be here, so L will start from here, R will start from here. So yeah, thank you guys, I think you understood. If you have any doubts, you can comment. Let's try to analyze the time complexity. This is if condition, this is also if condition. This two are taking k times for loop are there, so it will run for only k times. So if this condition is met, it will run for k times, it will go return from the function, so O of k, or it is running again O of k times. This binary search is taking log of n because there are n elements we are trying to find the target, and after we find the target, we are running these loops, 3 loops, but these 3 loops only be running till k times, k is greater than zeros. Yeah, so overall time complexity is log n plus k, and space complexity we are not using any space, so it is O of 1. But if you consider the answer vector what we are using, so that will be k. So it is as per expected log of n plus k, space complexity is k. So thank you guys.